Hello everyone. In the previous problem, we actually took a 2 by n matrix type and thought that we will be solving that particular problem graphically. But when we started checking for the dominance using the dominance property, we could able to reduce the matrix to a 2 by 2 matrix. So that time there was no requirement for us to solve it graphically. Now, in this particular problem, what we have taken in this question, consider the payoff matrix of player A as below, solve it optimally. We may not be able to reduce the matrix to a 2 by 2 matrix. So we will be doing a graphical method only to solve this problem. We'll see how do we go about it. As usual, to start with, we have to find the row minimum for each row. First row, the minimum is 1. Second row also, the minimum is 1. Then comes column maximum. First column, it is 4. Second column, 7, 8, 7, and 5. So we can now find out maximum value, which is maximum of row minimums, which is 1 and 1. So it becomes 1. Then mini max value, which is minimum of 4, 7, 8, 7, and 5. The minimum is 4. Consider this as 1 and this as 2. We may note that maximum value, which is 1, is not equal to the mini max value, which is 2. Hence, we conclude this game do not have a saddle point. The players are adopting mixed strategies. Now we will check for dominance. We'll be checking dominance only for columns because rows already it has got 2 rows only. So dominance check. Comparing first column 1 versus column 2. We may notice 4 is larger than 2, but 2 is lesser than 7. So I can say straight away, no dominance found. Then comes column 1 versus column 3. 4 is larger than 1, but 2 is lesser than 8. Again, we can say no dominance found. Then column 1 versus column 4. 4 is lesser than 7. 2 is greater than 1. Again, no dominance found. Then comes column 1 versus column 5. 4 is larger than 3. 2 is lesser than 5. Again, we have to say no dominance found. Now start with column 2 versus column 3. 2 is larger than 1. 7 is lesser than 8. Again, we can conclude no dominance found. Then C2 versus C4. 2 is lesser than 7, whereas 7 is greater than 1. So again, no dominance found. C2 versus C5. 2 is lesser than 3. 7 is greater than 5. Again, we have to say no dominance found. Now we have done comparisons of all column 2 with all the other columns. Now C3 versus C4. Column 3 and column 4. 1 is lesser than 7. 8 is greater than 1. So no dominance found again. Then C3 versus C5. Column 3 and column 5. 1 is lesser than 3, whereas 8 is greater than 5. So again, no dominance found. Then comes the last comparison, which is C4 versus C5, column 4 and column 5. 7 is greater than 3, whereas 1 is lesser than 5. Again, no dominance found. So we checked all the possible combinations, all the pairs of columns, and we found there is no dominance found. That means we will not be able to reduce this size of this matrix from 2 by 5 to anything lesser than 2 by 5. So we have to consider 2 by 5 only, 2 rows and 5 columns. Now we will start using the what you call graphical method. So we'll say first, let P1, P2 be the probabilities of player A adopting his strategies, 1 and 2 respectively. Since there are only two probabilities, we can say P1 plus P2 equal to 1, or I can say P2 is nothing but 1 minus of P1. This is about player A. This is player A actually. This is player B. Okay. Now, let us define the probabilities for player B. Let Q1, Q2, Q3, Q4, Q5 be the probabilities of player B adopting his strategies one, two, three, four, 5 respectively. Since these are the 5 probabilities possible for player B, we'll say Q1 plus Q2 plus Q3 plus Q4 plus Q5 should be equal to 1. We'll keep this much now. Now, let us find out. See, since we have 2 rows, solving this particular problem from A's perspective will be easier for us. Means we will be solving this from A's point of view. So we will say expected payoffs to player A with respect to WRT, with respect to various alternatives of B and values of expected payoffs of player A when A's probability P1 if it is 0 and P1 if it is 1. Just a minute. Sorry. I think I should rub this. It's going to. I'll write it in the next page. I'm sorry. Just a minute. Yeah. Create some pages. when we can say when P1 equal to 0, P1 equal to 0 and P1 equal to 1, because the probabilities least value can be 1, highest value can be 0. I'm sorry, highest value can be 1 and least value can be 0. So it will be easier if we substitute that to draw lines on a graph or below. So we are going to calculate these expected payoffs and values of the expected payoff. I will be creating a table below. Table having 7 rows and then 5 columns. Here, I'll merge these two. Here, I'll merge this. Here also, I'll merge this and this. Why? Because there are 5 alternatives for B's, 5 alternatives for B. So we'll say this first column as B's alternatives. Here we have A's expected payoff function. We'll be writing that particular formula. If P1 equal to 0, and here we will have if P1 equal to 1. Here we will have line reference. Here we will calculate the expected gain values. Let me auto fit this. Yeah. Okay. So now we have 5 alternatives: 1, 2, 3, 4, and 5. Here we'll call the references as, since it is, we are going to draw 5 different lines, I will call it as B1, B2, B3, B4, and B5. Line names I'm giving a reference to that. Now, how do we write down the expected payoff function? We'll go back to the table. Here, let me write the probabilities here. We already said A's probabilities are P1 and P2. This is Q1, Q2, Q3, Q4, and Q5. Right. Now, we can say first alternative. When B is using its first alternative, then A's payoff function will be 4P1 plus 2P2. 4P1 plus 2P2. 4P1 plus 2 times P2. We know P2 is nothing but 1 minus of P1. Here we already wrote it. Here it is, 1 minus of P1. So I'm substituting that. If I expand this or if I simplify this, it will be 2. Here you have 2P1 negative 4P1. So 4P1 minus 2P1 will become 2 times P1. Then next one, second alternative of B, 2P1 plus 7P2. 2P1 plus 7 times P2, 1 minus of P1. That can be written as 7 minus 5P1, because 2P1 here it is negative 7. 2P1 minus 7P1 will give you minus 5P1. Now, if third alternative is adopted by B, what is A's payoff function? 1 times P1 plus 8 times P2 means P1 plus 8 times P1 plus 8 times 1 minus P1. That will give you P1 minus 8P1 will be minus 7 times P1. Then fourth alternative of B, 7P1 plus P2. 7P1 plus P2. P2 is nothing but 1 minus of P1. So this I can write it as 1 plus 6P1. Then the fifth alternative of B, it is 3P1 plus 5P2. 3P1 plus 5 times P2 is 1 minus P1. That is 5. 3P1 minus 5P1 is minus 2P1. Now, if I substitute P1 as 0 here in this payoff functions, we'll get the value, expected gain value as 2 for the first one, 7 for the second, 8 for the third, 1 for the fourth one, and this will become 5. Now here we will have, if I substitute 1 for P1, 2 into 2 plus 2, so it becomes 4. This will become 2. This will be 1. This will be 7. This will be 3. So we got the coordinates now. So this graph is not like our regular graph. Here it will be like a unit graph. The graph will be like this somewhere. If we notice, all are taking positive values. So I can draw line like this. Something like this. Maybe we need maximum value I found is 8. So we can stop it here. And something like this. This measure, the horizontal measure is considered to be 1 unit. 1 unit. So here again, the vertical line. Let me little tilt it. Yeah, like this. It can be. It needs to be vertical. Right. So this is our, we are ready with our graph. So I'll put here 0, 1, 2, 3, 4, 5, 6. Here we will say P1 is 0. Here we will say P1 is 1. Means these are all fractions between 1 and 0. This horizontal line, starting with 0 and ending with 1. That is the meaning of it. So here again it is origin considered as 0. This one, 1, 2, 3, 4, and here 5, here 6. How much it goes up to? For 0, it is up to 8. For this one, it is up to 7. So one more, I will do it here. Here we have to do 2 more. This is 8 and this, I'm sorry, this is 7 and 8. This is 7, this is 8. Here it is 2, 3, 4, 5, 6, and 7. Now, if I have to draw B1 line at the left-hand side, that is P1 when it is 0, there I have to plot it on 2. And for right-hand side, when P1 is 1, I have to plot it on 4. So left it is 2, right it is 4. Left it is 2, right it is 4. Now join these 2 points. Yeah. Now, next, left it is 7, right it is 2. Join those 2 points. Then left it is 8, right it is 1. Here it is 8, here it is 1. Join those 2 points. Right. Then left it is 1, right it is 7. Primarily, let me first do it. 2 and 4 when we did, I should write that as B1. Here also, so that there is no confusion with the line. 7, 2, it is B2. 7, 2, it is B2. So here we say B2, here also B2. Then 8, 1. So this is B3. This is B3. Then 1, 7, that is B4. Then last one, 5 and 3. Left it is 5, right it is 3. Join those two. This is B5, B5. Now, this is about A's perspective, this problem, and I can say A, player A, is a maximin player since his objective is to maximize his minimum gains. So when we do the what you call shading, I'll be doing a shading below these all the lines, below all the lines. Means I can do shading like this. Let me put like this. Common area, common to all the lines, but it is downward because this fellow is looking for maximizing his minimum gains. Minimum gains will come down. Now among this, wherever we shaded, what are the corner points? One is this, one is this, one is this, and another one is this. So among all these corner points, the maximum point is this point. Let me call that point as P. Now we need to identify what is that P. We may note the P is an intersecting line of, what is this line? B3 and B1. We may note it is B3 and B1, or B1 intersection B3. This indicates, I can say which indicates that player B will be adopting his strategies 1 and 3, because it is B1 and B3, 1 and 3 only, and ignore his other strategies. Other strategies. That means, I can say, means what are all ignored? His first strategy will be there because it is B1 is there. I mean, first strategy is there. Q2 will not be there, means probability of adopting his second strategy will not be there. Q4 will not be there, and Q5 will not be there. All these will become 0. Means the probability of him adopting his second strategy, fourth strategy, and fifth strategy will be 0. So means, again, I can say then Q1 plus Q2 plus Q3 plus Q4 plus Q5, which is actually 1, will be now Q1 plus 0 plus 0. I'm sorry, not plus 0, plus Q3 plus Q3 plus 0 plus 0 will be 1, which means I can say Q3 is nothing but 1 minus of Q1. Now we can reduce the payoff matrix now. The reduced payoff matrix will be, it will become, because he has ignored his 3 strategies, so that means the table will become now 2 by 2. We can draw a 2 by 2 matrix. Player A, 1 and 2 strategies. Player B, which strategies? 1 and 3. 1 and 3. Now let us write the corresponding payoffs for 1 and 2, 8. Now we already know the corresponding probabilities are, for this it is P1 and P2. For this it will be Q1 and Q3. Now let us, since it is a 2 by 2 matrix, now we can directly go for the oddment algorithm, finding oddment for rows and also for columns. First one, modulus of 2 minus 8, which is 6. Then the next one, 4 minus 1 modulus, which is 3. Here it is 1 minus 8, which is 7. Here it is 4 minus 2, which is 2. So now we can find out what is P1. P1 is the corresponding oddment, which is 6, divided by sum of the row oddments, 6 plus 3. So it is 6 by 9. 3 2s are, 3 3s are. That means we can find out P2, which is 1 minus of P1, and that will be 1 minus of 2 by 3, which is 1 by 3. Same way, we can find out Q1, which is the corresponding oddment, which is 7. Sum of the column oddments, which is 7 plus 2. So it is 7 by 9. So Q3 is nothing but 1 minus of Q1, which is 1 minus of 7 by 9. That will become 2 by 9. So we got the probabilities now. We can find out the value of the game. Denoted by V, which is 4P1 plus 2P2. 4P1 plus 2P2, and that is 4 times 2 by 3 plus 2 times 1 by 3. That will give you 8 plus 2, 10 by 3. 10 by 3 is the value of the game. Now I can present the optimal strategies for both the players as A, open a bracket, write down P1 equal to, what is P1? 2 by 3. P2 is 1 by 3. Similarly, for player B, Q1 7 by 9. Q2, I'm sorry, let me write it properly. Q1 is 7 by 9. Then Q2 will be 0. Q3 is 2 by 9. Q4 and Q5 both are zeros. So that will be the optimal strategy. So we have got optimal strategies for both the players and also the value of the game. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends and also subscribe to my channel. Thank you.